Good morning, all of you students. Are you hearing my voice? What about video? Is video board is clearly visible to you or not? Okay, right. Yesterday, what is the topic we have completed? Yesterday, what is the topic we have completed? I think constraints, general constraints we discussed, I think. Am I right? Yeah, general constraints I discussed. Okay, today I want to discuss the another two types of constraints. They are the pulley constraints and wedge constraints. There are two different types of constraints are there. Okay. So next second one, in constraints, first types of constraints, first general constraints are over. Next second one, pulley constraints. Pulley constraints. Pulley constraints means whenever the two blocks or three blocks, whatever the number of blocks, whenever they are whenever two or more blocks are joined by means of strings and strings are passed over the light frictionless pulley, in such case, the motion of the bodies are restricted. Okay, in such case, whatever the relation among the motions of the different blocks, relation among the velocities, accelerations, distances traveled, these relations are called constraints. The relations among the kinetic parameters of the different blocks, whenever the motion of the some bodies are restricted by the motion of the other in the system, such type of relations are called pulley constraints. Okay, so we'll discuss one example. So example one in pulley constraint, already we know the Atwood mission. We know Atwood mission. First one, Atwood mission. Suppose when in the Atwood mission, two blocks are suspended. The two blocks are connected to, here you see, here it is the light frictionless pulley. It is the light frictionless pulley. Okay, string is passed over the light frictionless pulley like this. String is passed over the light frictionless pulley and two blocks are attached at the two ends of the strings. Two blocks are attached at the two ends of the string. Okay, so no doubt the weight M1Z acts. Suppose here these two blocks are released. If the mass of the two blocks are same, then the two blocks will be at equilibrium. That means there is no motion in the two blocks. Or if you push any body with certain speed, then the other body also travel with the same speed. If it comes down with a speed v, this also rises with the same speed. Or if they are at rest, then if the mass of the two blocks are same, the blocks remains at the same place only. That means they are under equilibrium. Okay, suppose if for our convenience, suppose M2 is greater than M1. M2 greater than M1. When the two blocks are released, at that time on this block, the force acts is weight. M1Z acts vertically downwards direction. Here the weight of this block M2Z acts vertically downwards direction. As M2 greater than M1, definitely this weight is greater than this weight. Okay, so here because of this weight, as the block is pulled downwards, at the same time the string pulls the block upwards with certain force called tension. Similarly, this block, because of weight of this block M1Z, it try to comes down, but at the same time the string pulls the block in opposite direction or upward direction by a force called tension. Okay, what about the accelerations of the two blocks? Are the accelerations of the two blocks are same or different? Are the accelerations of the two blocks are same or different? Different. This string this string is the inextensible string. This string is the inextensible string. Okay, that's why both blocks are having same acceleration. Already we derived that formula for acceleration also. M2 minus M1 into Z by M2 plus M1. We derived the formula for acceleration also. That's why the two blocks travel with the same acceleration. Already we derived formula also. We proved. Okay. So is it correct or not? By constraint principle also we can verify. Okay. So here you see to write the constraint principle, there are different methods to write the constraint relations. Constraint relations means, suppose no doubt as the weight is more here, the acceleration of this block is say A1, acceleration of this block is say A2. Okay, this block comes down with an acceleration A1, this block, if it comes down, it rises up. Or if it comes down, it rises up. That is the relation. Okay, suppose I imagine as M2 greater than M1, definitely this block comes down, this block rises up. Okay, is it correct or not? We have to check. Now you see, here to write the constraint relation between the accelerations of the two blocks. First, in the system, there are two blocks and pulley is there. Which is the fixed body? Which body is fixed in the system? No, Vishnu, accelerations are equal in magnitude. No. Whenever this block comes down with acceleration A2, this block rises up with the same acceleration because this is totally the same string. With what acceleration this string comes down in this direction, it rises in this direction. That's why accelerations are same. Accelerations are same in magnitude, Vishnu. Accelerations are same in magnitude. Yeah, pulley is fixed. So here in this system of pulley two blocks, the pulley is fixed. So first we have to identify which in the system which body is fixed. So pulley is fixed. From the fixed body, you write the distances of the different bodies in the system. So this is the fixed body, no? This is fixed body or fixed pulley. From the fixed pulley, the distance of this first block, the distance of the first block is say y1. The distance the distance of the second block from the fixed pulley, that is say y2. It is the small pulley. The length of the string over the surface of the pulley is negligible. It is the small pulley. That's why when compared with these lengths, the length of the string over the surface of the pulley, that means up to this, that is negligible. From this position, we measured the length of the string. What is the total length of the string? Total length of the string. Suppose if you take this length of the string from this position to this position, this length of the string is say L0. Of course, this is negligible. We need not write. Even then, if you say that is L0, okay. What is the total length of the string you write from these dimensions? What is the total length of the string? It is y1 plus L0 plus y2. Okay, y1 plus L0 plus y2. It is the total length of the string say L, or y1 plus y2 is equal to L minus L0. Okay. Even the blocks move like this. Even the blocks move. This is in upward direction, this is in downwards direction. Is there any change in the length of the string? This string is the inextensible string. This string is the inextensible string. That's why is there any change in the length of the string? No, there is no change in the length of the string. Total length of the string L remains constant. While the blocks move, one block move downwards, another block move upwards. Is there any change in the length of the string over the pulley? Is there any change in the length of the string over the pulley? Is there any change in the length of the string over the pulley? No. Very good. That means this is also constant. Even the two blocks move. Two blocks are in motion. Okay. Now you here this is equal to constant. This is equal to constant. So y1 plus y2 is equal to constant. That is equal to say some a constant. Say capital L. This constant is capital L. Say okay, constant. Now we differentiate them with respect to here. This is one constraint relation between displacement distances of the blocks from the fixed pulley. Okay. Next, now we differentiate this with respect to time. On differentiating with respect to time, comma then why? Because whenever the two blocks are released, this block goes up, this block comes down, means y1 value decreases with time, y2 value increases with time. No, that means this y1, y2 values are changes with time. Y1, y2 values are changes with time. L0 is the already said. No, here in the diagram also there it is. L0 is the length of the string over the pulley from this position to this position. Vishnu. Okay. Okay, Vishnu. right? So now on differentiating this equation with respect to time, then d by dt of y1 plus y2, d by dt of y1 plus y2 is equal to d by dt of L. So dy1 by dt plus dy2 by dt is equal to, as it is constant, when you differentiate them, you will get 0. What about dy1 by dt? What about dy1 by dt? dy1 by dt is the rate of change in the length of the string here, no? That means rate of change in y1 value, no? Rate of change in y1 value. Whenever the block comes down here, as the block moves up, this y1 value decreases. That's why dy1 is the decrease in length of this string in a time dt seconds. So dy1 by dt is the rate at which the length of the string decreases, which is equal to velocity with which the body rises. And at what rate the length of the string decreases here, at that rate the block moves upwards. That's why suppose the velocity of this block is say v1 at certain instant, then this is minus v1 we have to write, because dy1 decreases. dy1 decreases. Okay. Or in other words, you keep like this only. You keep like this only, no problem. v1 plus, this is what about dy2 by dt? That is, suppose at any instant of time, whenever the velocity of this block is v1, velocity of this block is say v2. Then dy2 by dt means that is the rate of change the length of this string. y2 is the length of this string. dy2 by dt means rate of change in the length of the string. That is equal to at what speed the block moves, at the same rate the length of the string here changes. That's why dy2 by dt is the velocity of the block 2. That is equal to 0. Or v2 is equal to minus v1. v2 is equal to minus v1. Here minus represents these velocities are not exactly in opposite direction. The meaning of minus is not exactly in opposite direction. v1 v2 are in different directions. v1 v2 are in different directions. Here minus sign does not represent both are in opposite direction. Of course here they may be in opposite direction, but here minus sign represents v1 v2 are not along the same, not in the same direction. They are in different directions here. So this is the one constant relation between the velocities. Okay. Here minus sign represents negative sign. Negative sign represents blocks travel in different directions. Different directions. Okay. Next, v1 plus v2 is equal to 0. No, this is one constant relation. This is the one constant relation 1. It is one constant relation 2. Next, from 2. v1 plus v2 is equal to 0. Again, you differentiate them. Then dv1 by dt plus dv2 by dt is equal to 0. Or dv1 by dt means acceleration a1 plus a2 is equal to 0. This is one more constant relation. This is equation 3. Or a1 is equal to minus a2. That means the accelerations of the two blocks are same in magnitude. a1 is equal to minus a2 means they are equal in magnitude, but minus sign represents they are in opposite direction. If a2 is in downwards direction, a1 is equal to minus, no, that's why it is in opposite direction, but they are equal in magnitude. So from this also it is clear that they are equal in magnitude. So this is the constant relation for the two blocks in case of actual mission. In this way, we had to write the constant relation. Okay. Right. Next, one more example I want to discuss. Okay. Shall I write this one? Here, the same method can be, the same problem can be noted by power method. That is easy, because for always in all cases it is difficult to write the constant relation in terms of lengths. In terms of lengths, it is difficult because we have to choose the fixed body. From that, we have to measure the length of the strings and we have to add them, differentiate them like this. Instead of that, the zero power concept is there. By zero power concept, zero power concept, by zero power concept, by zero power concept also we can find easily. Zero power concept. Actually, suppose when the force and velocity both are in the same direction, what is the formula for power? Tell me. I think you know the formula for power. power is equal to work by time. Am I right? Power is equal to, you see, power P is equal to work by time. Do you know the power formula or not? Have you heard the power or not so far? Power మీకు ఇప్పటిదాకా విన్నారా లేదా అసలు? Of course I don't want the formula, ask you formula. You heard, okay. Power is equal to work by time. Work means displacement F into S by time. F into displacement by time means velocity, no? So power can be written as F into V, no? Of course, work done is equal to F bar dot S bar, Fs cos theta. Suppose F and S both are in the same direction, then Fs cos 0 means Fs by time. Here in t seconds, because of this force, the displacement of the body is S. Then displacement by time is the velocity. So force into velocity is the power. Or already I said in vectors, I think, as force and velocity are both are vectors, power can be written as dot product of F bar dot V bar. I said this point also in vectors. Okay, I said. So in order to find the power, force into velocity is the power. By that method we can find. Okay, now by zero power concept here. So whenever in a system of different blocks and pulley, in a system there are different pulleys or blocks. Here the total power consumed by the tensions in all the strings, the total power consumed by tensions in all the strings is equal to 0. That is the zero power concept. The total power consumed by or total power utilized by the tension the strings in moving the blocks, that is equal to 0. The net power consumed by the tensions in the strings in moving the blocks is equal to 0 in any system, in the given system. For any system we can apply this method. Okay, so by that method, so here you see here what is the power consumed by this tension in moving the block m1 with a velocity v1? Tell me, ఇక్కడ ఈ టెన్షన్ వల్ల ఎంత పవర్ కన్జ్యూమ్ అవుతుంది? ఈ టెన్షన్ వల్ల ఎంత పవర్ కన్జ్యూమ్ అవుతుంది? ఇక్కడ ఈ టెన్షన్ తోటి బ్లాక్ ని పైకి v1 స్పీడ్ తో మూవ్ చేస్తామని అనుకుందాం. అప్పుడు t ఇటువైపుకి ఉంది, v1 కూడా ఇటువైపుకి ఉంది, కాబట్టి పవర్ కన్జ్యూమ్డ్ ఈజ్ ఈక్వల్ టు t ఇంటూ v1. t v1 cos 0 అంటే t v1 కదా, t ఇంటూ v1. ఓకే, నెక్స్ట్ ఇక్కడ పవర్ కన్జ్యూమ్డ్ బై దిస్ టెన్షన్, ఇక్కడ v2 ఇటువైపుకి ఉంది, t ఇటువైపుకి ఉంది, అంటే ఆపోజిట్ డైరెక్షన్ లో ఉన్నాయి, ఆపోజిట్ డైరెక్షన్ లో ఇక్కడ ఉన్నాయి మనకి. ఓకే, పవర్ కన్జ్యూమ్డ్ బై దిస్ టెన్షన్ అంటే ఏం రాస్తాం? పవర్ కన్జ్యూమ్డ్ బై దిస్ టెన్షన్ ఇన్ మూవింగ్ ద బ్లాక్ m2 ఈస్ t v2 cos, t ఇటువైపుకి ఉంది, v2 ఆపోజిట్ డైరెక్షన్ ఉంది కాబట్టి జస్ట్ మైనస్ రాయాలి అంతే, మైనస్ tv2 is equal to 0, no? Or t cancel, so v1 is equal to v2. When v1 is equal to v2, a1 is equal to a2, no? These are the relations, constant relations. These are the constant relations. From this also it is clear that suppose at any instant of time, if the velocity of the first block in upward direction is v1, velocity of the second block is also same v2, same equal to v2 is equal to v1 only, but in opposite direction. Okay, similarly accelerations are also same in magnitude, already I said. So by zero power concept we can do like this. Sometimes in some cases, you see here on this block, one time tension, 1 into t, one time tension only control the motion of this body. ఇక్కడ t అంటే ఓన్లీ 2t కాదుగా, 1t నే కదా ఉంది, అంటే వన్ టైం టెన్షన్ ఈ మోషన్ కంట్రోల్ చేస్తాం కాబట్టి 1 into v1 we can write simply. అయితే టెన్షన్ వెలాసిటీ రెండు సేమ్ డైరెక్షన్ ఉన్నాయి కాబట్టి 1 into v1. ఇక్కడ కూడా వన్ టైం టెన్షన్ కాబట్టి 1 into v2, కానీ ఇక్కడ ఆపోజిట్ డైరెక్షన్ ఉన్నాయి కాబట్టి టెన్షన్ వెలాసిటీ -1 into v2 అని రాస్తాం. సో v1 -1 into v2 is equal to 0, or v1 is equal to v2. ఇది పవర్ కన్జంప్షన్ అండి, పవర్ కన్జంప్షన్ 0 కాబట్టి 0కి ఈక్వల్ చేసేయండి, దాని నుంచి మనకి రిలేషన్స్ వచ్చినాయి. ఇంకొక ఎగ్జాంపుల్ డిస్కస్ చేస్తే దెన్ యూ విల్ గెట్ సమ్ మోర్ క్లారిటీ ఇన్ రైటింగ్ ద కన్స్టెంట్ రిలేషన్స్. ఓకే, సో దిస్ ఇస్ వన్ ఎగ్జాంపుల్. సో బెటర్ టు ఫాలో దిస్ జీరో పవర్ కాన్సెప్ట్. Second example. Okay, example 2. Example 2. Okay, here by means of two pulleys, suppose this is the rigid support. It is the rigid support. One pulley is here. One string is fixed to the rigid support here, and it is passed over the pulley, and this string is passed through another pulley arranged here. The pulleys may be the same size or may not be. Okay, here the string is passed over the another pulley like this, and here at the other end of the string one block is suspended. One block is suspended. Here from the center of the pulley another block is suspended like this. There are two blocks are suspended like this. Okay, so here it is say M1 and here it is say M2. Two blocks are suspended. Okay, suppose the acceleration of this block is say A1, acceleration of this block is A2, or at any instant if the velocity of this body is say V1, velocity of this body is say V2, in which direction the blocks will move? Suppose you take this velocity of the block moving downwards, then definitely when it move downwards, just imagine if the block move downwards, then this string will rise. When this string will rise, then this pulley will be moved up. Whenever pulley moves up, then this block M2 rises up. Okay, so in such way we can imagine. Okay, or in other words, in which direction the blocks will move? First of all you imagine the blocks are under equilibrium. The blocks are under equilibrium. You imagine here tension is T, no? Here tension is T. Suppose you imagine this is the tension T. As it is totally the same string, ఈ మొత్తం ఒకే స్ట్రింగ్, ఈ రెండు కూడా లైట్ ఫ్రిక్షన్లెస్ పుల్లీస్ కాబట్టి మొత్తం సేమ్ స్ట్రింగ్. ఒకవేళ ఇక్కడ పుల్లీస్ కనుక ఫ్రిక్షనబుల్ అయితే అప్పుడు ఇక్కడ టెన్షన్ డిఫరెంట్ గా ఉంటాయి. కానీ లైట్ ఫ్రిక్షన్లెస్ పుల్లీస్ కాబట్టి వాట్ ఎవర్ ద టెన్షన్ హియర్, the same tension is developed in this string, the same tension developed in this string, because this is totally the same string. Okay, that's why same tension developed here and here also. Of course, when you consider this pulley, tension in the string is away from the pulley. ఈ పుల్లీ కన్సిడర్ చేస్తాం అనుకోండి, టెన్షన్ ద పుల్లీ is in this direction, away from the pulley. ఇక్కడ కన్సిడర్ చేస్తే away from the pulley. Okay, here this pulley is pulled upwards with the total force how much? This pulley is pulled upwards with total force how much? On this pulley is pulled upwards by means of these two strings. By means of these two strings. That's why 2T force acts on the pulley in upward direction. Okay, so at the same time whenever the 2T force acts on the pulley in upward direction, at the same time here also the tension becomes 2T. Here the same tension 2T acts in this direction, or same tension with the same tension 2T, this block is pulled upwards. This block is pulled upwards. Or in other words, suppose if you consider the block here, here tension is say 2T. Then if you consider this block, this tension is away from the block. If you consider the pulley, the same tension is in this direction. 2T tension is in this direction. Because it is the same string, tension here, at every point of the string remains the same, as it is light string. Okay, now you see what is the here in this way. First you write, whenever the, suppose if the blocks are in equilibrium, if the blocks are in equilibrium, then T is equal to M1Z, 2T is equal to M2Z, 2T is equal to M2Z. Okay, here from this, is M2 is more or M1 is more? Tell me, is M2 is more or M1 is more? Is M2 is more or M1 is more? Is M2 is more or M1 is more? Okay, here 2T is equal to, you see 2T is equal to weight M2Z. So T is equal to M2Z by 2. అంటే దీని వెయిట్ లో హాఫ్ ఆఫ్ ది వెయిట్ టెన్షన్, అంటే తక్కువ వెయిట్ తక్కువ ఉన్నట్లే కదా. మరి వెయిట్ తక్కువ ఉంది కాబట్టి సపోజ్ if this, whenever these two blocks are released, suppose this block rises up, you imagine, no problem, if you imagine this block moves up, this block comes down. Okay, సో ఇక్కడ ఈ బ్లాక్ సపోజ్ అప్పర్ డైరెక్షన్ మూవ్ అవుతుంది, ఇదేమో డౌన్వర్డ్స్ డైరెక్షన్ లో మూవ్ అవుతుంది అనుకుందాం. ఓకే, లేదు ఇది డౌన్వర్డ్స్ తీసుకోండి, ఇది అప్వర్డ్ తీసుకోండి, మన ఇష్టం ఏదైనా తీసుకోవచ్చు. సో ఇక్కడ suppose this block moves down with an acceleration A1, this block moves upwards with an acceleration A2, say. ఓకే, ఎందుకంటే ఇక్కడ టెన్షన్ ఎక్కువ ఉంది కాబట్టి, ఎక్కువ ఫోర్స్ పనిచేస్తుంది కాబట్టి ఇది ఇటువైపు మూవ్ అవుతుంది అనుకుందాం మనం ఫర్ ఎ మూమెంట్. యాజ్ మోర్ టెన్షన్ ఫోర్స్ యాక్ట్స్ ఆన్ ది బ్లాక్ హియర్, ఇట్ రైజెస్ అప్. ఇది ఎప్పుడైతే పైకి వస్తుందో ఆటోమేటికల్లీ డెఫినెట్లీ ఆబ్వియస్లీ దిస్ బ్లాక్ కమ్స్ డౌన్. నౌ యూ అప్లై ద జీరో పవర్ మెథడ్, జీరో పవర్ కాన్సెప్ట్ హియర్. బై జీరో పవర్ కాన్సెప్ట్, zero power concept. Tell me, tell me for this block first. By zero power concept, you tell me. By zero power concept, how we can write? Velocity is v1, tension is this one. Here we imagine that the block moves downwards, v1. Okay, tension is upwards. That's why minus t into v1 we have to write. Okay, that is the power consumed by this tension in moving the block with a velocity v1. For this, 2t acts upwards and body also move upwards only. Okay, v2. That's why 2t plus 2t into v2. This is the total power consumed by all the tensions on the blocks in moving them. That is equal to 0 according to zero power concept. So from this we can have v1 is equal to 2v2. No, v1 is equal to 2v2. This is the constraint relation for these blocks. It is the constraint relations. Okay, if the block v1 comes down, if the block this mass m1 comes down with a velocity v1, then v2 is equal to v1 by 2. v2 is equal to v1 by 2. అంటే ఇది v1 velocity మూవ్ అవుతుంటే ఇది దాంట్లో హాఫ్ ఆఫ్ ది వెలాసిటీ తో పైకి మూవ్ అవుతుంది, హాఫ్ ఆఫ్ ది వెలాసిటీ తో పైకి మూవ్ అవుతుంది. ఓకే, అదే యాక్సిలరేషన్స్ రిలేషన్స్ అంటే దీని విత్ రెస్పెక్ట్ టు టైం డిఫరెన్షియేట్ చేస్తే అప్పుడు a1 is equal to 2 into a2 రాసుకోవచ్చా? a1 is equal to 2 into a2. This is the relation between the accelerations or distances traveled. Here this can be written as ds1 by dt, ds2 by dt. When integrate dt cancel, when integrate them, then you will get s1 is equal to 2s2. That means whenever this block comes down through a distance equal to s1, this block comes down through a distance s1, then this block rises up through a distance s2, which is equal to s1 by 2. That means half of this displacement, half of this displacement. Okay, so this is the constraint relation. Next, example 3. We will discuss one more example. We will discuss the one more example. In this way we can write the constraint relations. Okay, here there are, now based on this concept you can say very simple manner. What is your doubt, Likit? What is our doubt, Likit? Because 2t force is more than this one. No, 2t is greater than this t. That's why it rises upwards, it falls down, it comes down. First concept, this one, Likit, which one you need? So similarly you write that for active mission also. Similarly you write for active mission. No, here actually, here on this block only it tension T only controls the motion of this body. Here 2T tension controls the motion of this body. That means in this upward direction more tension acts. That's why for our convenience, mathematically to have the convenience, as more tension acts on the block in upward direction, you take this motion is in upward direction, this motion downwards. Suppose if you imagine wrongly, when you calculate them, then you will get this as negative and this as positive. మనం తీసుకుని ఇది ఇటువైపు ఉన్నట్టుగా తీసుకుని ఇటువైపు తీసుకుని చేసాం అనుకోండి, ప్రాబ్లం సింప్లిఫై చేయండి. అప్పుడు a1 నెగిటివ్ వచ్చింది అనుకోండి, అప్పుడు a1 మనం ఇటువైపు తీసుకుని చేసాం. బట్ వీ హావ్ కన్సిడర్ ద మోషన్ ఆఫ్ ది బ్లాక్ a1 డౌన్వర్డ్స్. If you get a1 negative, that represents the block m1 moves upwards with acceleration a1 and it comes down with an acceleration a2. In such a way you will get. Okay, zero power, the total power consumed by tension on the all blocks in moving all the blocks in a system of pulley blocks is 0. m1 is having more velocity. Okay, whatever the velocities, Whatever the velocities, the direction is important. Whatever the velocities, directions are important. Okay. Here, first diagram is given like this. Suppose as it is the same string, you write the tension here T. As this is a total, it is the same string. The same tension is there in the given string. Here, all are same strings. If it is T, T. It is different. It is different. That's why, or in other words, you take this as T1, T1, T1. It is a T2. In such a way also we can imagine, if it is T1, T1 is equal to say T. This is also T1. This is also T1. Of course, T1 is equal to T. Okay, this is also equal to T. Okay, here it is say T2. On the pulley, T1, T1. That means 2T1 acts in upward direction and T2 acts downwards direction. On this pulley, 2T1 tension acts upward direction, T2 tension acts in downwards direction. Okay, so what is the net force acts on the pulley? Net force acts on the pulley. That means 2T1 minus T2 we can write, or T2 minus 2T1 we can write. Okay, this is the net force acts on the pulley. Already in the instructions only, I said that two pulleys are light frictionless pulleys. That's why actually this is equal to mass into acceleration of the pulley. But mass of the pulley is 0, whatever the acceleration. Therefore, 2T1 minus T2 is equal to 0, or 2T1 is equal to T2. If T1 is equal to T, then T2 is equal to 2T. I use it that directly. I use it. T1 direct ka T అని తీసుకున్నా అప్పటిక 2T వస్తాం. Okay. Next, one more example. With number of pulleys, we have to draw the diagram. Simply we can say, suppose this is the rigid support, horizontal support. Here there is one pulley. Here one more pulley. Here one more pulley. Different pulleys are there like this. All these are suspended from the rigid support like this. All these are suspended from the rigid support like this. Okay. One string is passed over this pulley. One string is passed over this pulley. Okay. And here it is passed through another small pulley like this. Like this. Okay. Here this string is passed over the another pulley like this. And here one string is fixed to the pulley like this. Here this string is passed over the pulley, and it is passed through another pulley kept here. Another pulley kept here and passed over the other pulley. And here the string is passed over the pulley like this. This pulley is also connected to string. Okay, now all these lower ends of the strings are joined to a horizontal block. A horizontal block. Horizontal block. This is the block. Block of mass capital. Block of mass capital. Okay. No. This is connected to okay. Here this plank is connected to this one. Here the mass, here one block is fixed at this end. One block is fixed at this end. This is the block. In this way, a plank and a block both are fixed. Mass of the plank is say M1. Mass of the plank is M1. Mass of the block is say M2. Now, whatever the constraint relation, whatever the relation between the accelerations and velocities at any instant of time, suppose you see, as it is the totally the same string, if the tension here is say T, tension is always away from the block. If the tension here is say T, then you see, as it is the same string, tension here is T, tension here is T, tension here is T, tension here is T, and same tension acts at this point also, T, because it is totally the same string, no? Okay, now you see whatever the tension here, you tell me. Previously I said just now, whatever the tension here, if it is T and here T, what is the tension here? You tell me. 2T, very good. Because on the pulley in upward direction, 2T force acts. That's why the 2T force acts on the pulley downwards, and same 2T force pulls the plank in upward direction. That's why 2T. Whatever here, What about the tension here in this string? In this string also tension is 2T only. Okay, very good, 2T. So here also tension is 2T. Now we have written the tension concepts. Okay, now at any instant, no doubt the motion of this plank is controlled by totally what tension the motion of this block is controlled? Totally what tension acts on the plank? Move the plank 5T. Very good. Because 2T, 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 all these are in upward direction. That's why 5T tension control moves the plank upward direction. Here only T only. As this tension is more, suppose this plank move upwards with a velocity say V1, acceleration A1 at certain instant. At the same time, definitely whenever this plank move upwards, definitely this comes down now. That's why this plank comes down with acceleration A2 and velocity V2. Okay. Now tell me constraint relation for this plank and block. So according to zero power concept, by zero power concept or zero power consumption concept. Tell me. Here on this entire plank, 5T tension controls the motion of this plank. So 5T tension upwards and velocity of the plank is also taken upwards only. So 5T into V1. Next here for this block, T into V2, but V2 is in opposite direction, T is in upward direction, V2 is in downward direction. That's why minus T into V2 is equal to 0. Okay, therefore T can be cancelled. So 5V1 is equal to V2. This is one constraint relation. Or in other words, suppose if you differentiate them with respect to time, then 5A1 is equal to A2. 5A1 is equal to A2. Suppose if the acceleration of this block is A2, the acceleration of this plank is equal to 5. Of course, A1 is equal to A2 by 5. దీని యొక్క యాక్సిలరేషన్ A2 అయితే దీని యొక్క యాక్సిలరేషన్ A1 is equal to A2 by 5. అంటే దీని యొక్క యాక్సిలరేషన్ లో 1/5 ఆఫ్ యాక్సిలరేషన్ తో ఈ బ్లాక్ ఈ పుల్లీ ట్రావెల్ చేస్తుంది, ప్లాంక్ ట్రావెల్ చేస్తుంది. So this is the one more constraint relation. In this way we can write the constraint relations. It is 1 and it is 2. In this way we can write the constraint relations. Okay. Now these are the some constraint relations. Generally in our mains or advanced, with 2 pulleys or 3 pulleys only, they are generally they used to give the problems. Multi pulleys unnai, oka 6, 7, 8 pulleys like that. Generally they are not asking the problems related to more number of pulleys. These are enough. Okay. Now yes, in case of displacements also very good. Suppose if the displacement of this body is S2 downwards, it is say S1 upwards, then 5S1 is equal to, very good, 5S1 is equal to S2 we can write. This is also we can write. Of course 5S1 is equal to S2, 5V1 is equal to V2, 5A1 is equal to A2. Suppose if you want to find accelerations of the, okay, while doing problems we can have idea. So this is one pulley constraints. Okay. Now wedge constraint. In constraints last model, wedge constraint, third one. Third one, wedge constraint. Wedge constraint. So here, suppose initially there is a block, there is a wedge. Initially there is a wedge. Smooth wedge. Here this is the initial position of the wedge. Initially the wedge is here, it is kept on the smooth surface. It is kept on the smooth horizontal surface, smooth surface. Okay, the wedge is kept on the smooth horizontal surface. Every surface of the wedge is also smooth. Angle of inclination is say theta. This angle of inclination is theta. Here, this is one wedge. This is one wedge. It is kept on the smooth horizontal surface. The inclined surface of the wedge is also smooth. Over this wedge, one block is kept. Over this wedge, one block is kept like this. The mass of the wedge is say capital M. Mass of the plank is say small m. Mass of the block is say small m. Mass of the wedge is say capital M. All are smooth surfaces. In between these two also there is no friction. All are smooth. When you release the system, that means when you release the block, what about the motions of the wedge and block? Tell me. What about the motions of the block and wedge? In which direction block travel? In which direction wedge travel? In which direction block travels? In which direction wedge travels? Not, I am not asking what is the velocity of the block, what is the weight of the block, etc. When you release them, in which direction they move? Wedge move backward means are you? I think you are saying towards left. Pujit. Okay, Amarnath. Downwards means which will travel downwards? Wedge leftwards. Very good. Next. Varshit. Very good. What about block? Block will move. Block will move. Of course, the block comes down. At the same time, whenever the block comes down, wedge travel in this direction. So block comes down, and at the same time, block to move towards right. Block, they move downwards, and at the same time, simultaneously, they move towards right also. They move towards right. What is the reason? What is the reason? Why the wedge move towards left? When you release the entire system like this, why the wedge move towards left? Why the wedge move towards left? Tell me, anybody else? Which force? Okay, no doubt. Force applied by block. What we call force applied by block on the wedge? What we call the force applied by block on the wedge? Contact force. Okay, because of contact, some force acts. We call that force as a particular name, no? Yeah, normal force. Very good. Normal force. At any instant here, whenever the block is here, you see, perpendicular to the plane of contact. Perpendicular to the plane of contact. Of course, weight acts in downwards direction. Perpendicular to the plane of contact, you draw a normal. In this direction, you draw a horizontal line parallel to inclined surface. Okay. If it is weight mg, this is, of course, this angle is theta. This angle is theta. Weight component mg sin theta, mg cos theta acts in this direction, mg sin theta acts in this direction. But here, if the wedge is fixed, no doubt we can write mg cos theta is the weight. Mg cos theta is the weight component perpendicular to plane of contact, acts exerted by block on this inclined surface, we can say, but this block is also in motion. That's why it cannot exert the it cannot exert the normal force equivalent to weight component mg cos theta. Suppose in this direction, say normal force is say n. In this direction, normal force is say n. Okay, you resolve this normal force into components. One component in this direction, this normal force component in this direction, one normal force component in this direction. Of course, if it is theta, it is theta. So this component is n sin theta. Because of this n sin theta, normal force component acts on the wedge. The wedge will move towards left. Suppose after some time, here I don't want to write these components here, but because of normal force component, the wedge will move. I will draw in another diagram. I will represent normal force everything in another diagram. Okay, here you see. So here, no doubt, because of this normal force component, wedge move in this direction. Suppose after some time, wedge displaces through certain distance. Wedge comes to this position. This is the position of the wedge after some time. Here, at the time, the block comes to the position here, say. At this time, of course, nothing wrong. I will draw the block here. Initial position of the block is here. Final position of the block is now here. I want to draw. Final position of the block is here. That means whenever the block and wedge system is released, because of normal force component acts on the wedge towards left, the wedge move towards left, and at the same time here normal force acts on this block in this direction. So their component acts in this direction. Due to that, it move along horizontal direction, and at the same time, because of weight component, the weight component pulls the block along the incline downwards. That's why it moved downwards and it traveling forward direction also. Okay. Now, what is the distance traveled by the wedge? You see, suppose distance traveled by the wedge is say SW. Distance here at the instant whenever the block comes from this position to this position. Okay, what is the distance traveled by the wedge? You see, whenever the block comes from this position to this position, as the wedge displaces up to this is the distance traveled by the wedge towards left now. At the same time, perpendicular to the inclined plane. At the same time, perpendicular to the inclined plane, what is the distance traveled by the block? Initially, the block is here. Whenever the wedge has displaced through a distance SW, when the wedge has displaced through a distance SW, the block comes to this position. That means perpendicular to incline. What is the distance traveled by the wedge? Perpendicular to incline. This is the distance traveled by the wedge, you know. Perpendicular to incline. This is the distance traveled by the wedge, you know. Inclined plane ki perpendicular ga ante ee direction lo block ఎంత distance travel చేసింది అంటే ఇక్కడ నుంచి ఇక్కడ దాకా వచ్చింది కాబట్టి ఈ డైరెక్షన్ లో ట్రావెల్ చేసిన డిస్టెన్స్ ఇదే కదా అంటే ఇదేగా ఈ డిస్టెన్స్ ఏగా ఈ రెండు సేమేగా this is the distance traveled by the block perpendicular to the inclined plane, that is the SB. ఇక్కడ ఎంత డిస్టెన్స్ ఉందో ఇక్కడ కూడా అదే డిస్టెన్స్ ఉంటుందా ఇది this is SW. Are you followed this one? No doubt, as it is the perpendicular distance, definitely here 90. Now, what is the relation among these displacements of the block and wedge? Tell me. What is the relation between displacement of the block and displacement of the wedge? We can have sin theta. Sin theta is equal to opposite by hypotenuse, no? So from the diagram, sin theta is equal to opposite means SB by hypotenuse means SW, or SB is equal to SW into sin theta. This is the wedge constraint. It is called wedge constraint. Wedge constraint. So you have to see that this SB is the displacement of the block perpendicular to the inclined plane. That is very, very important. SB, that is the displacement of the block. Displacement of block perpendicular to incline. Perpendicular to incline. And SW, displacement of wedge along horizontal direction. That is very, very important. At certain instant of time, if the velocity of the wedge in this direction is say VW, velocity acceleration of the wedge is say AW. At the same time, perpendicular to the incline, that means in this direction, velocity of the block is say VB, velocity of the acceleration of the block is say AB, perpendicular to the incline. What is the relation among them? Now you tell me. The remaining other two constraint relations, you tell me wedge constraints. If SB is equal to SW into sin theta, definitely if SB is equal to SW into sin theta, definitely velocity of the block perpendicular to the incline is equal to velocity of the wedge into sin theta. Similarly, acceleration of block perpendicular to the incline is equal to acceleration of the wedge into sin theta. This is one example for wedge constraint. Okay. Another example, last example, one more example for wedge constraint. Of course, here we can derive the formula for acceleration of the block also. Here we can derive the formulas for acceleration of the block also. How we can derive? Here already we have the wedge constraint, no? This is say equation 1, 2, 3. Shall I erase this one? I will erase this one. Okay, from this formula, sin theta is equal to SB by SW, or SB sin theta is equal to SB by SW. SB is equal to SW into sin theta. Okay. Next, VB is equal to VW into sin theta. AB is equal to AW into sin theta. Here AW is the acceleration of the wedge along horizontal direction. AB is the acceleration of the block perpendicular to the incline. Ante E direction lo acceleration. This is say equation 4. All together that is say 4. Okay, now I will erase this also, because I need the space to derive the formulas for A and AB. Acceleration of the wedge and acceleration of the block. Okay. So now for free body diagram of the block, I have to write free body diagram of the block. Free body diagram of block. What are the forces acts on the block? What are the forces acts on the block perpendicular to incline? Here block is on incline, no? Here this is the position of the block. Actually, weight mg acts in this direction. Weight mg acts in this direction. Okay, and normal force, because of this inclined surface, normal force acts on the block in upward direction. No? So normal force acts on the block in upward direction. N. Okay, of course, this is weight mg. Now resolve this weight mg into components along perpendicular to the incline. That means in this direction. Of course, we know already I said here weight direction is this one. This is theta, no? So this angle is theta. Whatever this component, mg cos theta. Now perpendicular to the incline, what are the forces acts on the block? Perpendicular to incline, what are the forces acts on the block? Perpendicular to incline, what are the forces acts on the block? N along this direction, mg cos theta along this direction. Okay, they are in opposite direction. Even then, whenever the wedge move in this direction, as the block comes down, mg cos theta greater than n, no? So what is the net force acts on the block perpendicular to incline? Perpendicular to incline. Perpendicular to incline. Perpendicular to incline. Net force acts on the block is equal to mg cos theta minus normal force, no? Perpendicular to incline, the net force acts on the block is equal to mg cos theta. Mg cos theta means, okay, small m is mass of the block. Of course, I substitute, I noted already here. Okay. And capital M is the mass of the wedge. Okay. Mg cos theta minus n. It is the net force acts on the block along the perpendicular to the incline. That is equal to, as this force is, this weight is greater than this one, then net force is equal to mass of the block into acceleration of the block perpendicular to incline. That is imagined as AB only, no, in this direction. So acceleration of the block perpendicular to incline is AB. That's why this is equal to m into AB. So from this, normal force is equal to, or normal reaction is equal to mg cos theta minus m into AB. This is equation 5. It is for block. Similarly, what about the formula for wedge? Free body diagram of the wedge we have to write. Free body diagram of the wedge we have to write. Okay. So mg cos theta minus mb into AB we have written. Now, in order to find the formula for acceleration of the block AB, in order to find the acceleration of the block AB, okay, keep like this. Suppose if you want to find the acceleration of the wedge first, AW. So from this formula we can write n is equal to mg cos theta minus m into, what about AB? AW sin theta we can write, no? AW sin theta we can write. This is equation 6. Now, free body diagram of wedge. Free body diagram of wedge we have to see first. Okay, free body diagram of wedge. Here this is the wedge. Of course, this is say wedge. This is the wedge. Free body diagram means we have to represent with the dot only actually. So in order to understand here, suppose this is the wedge. Okay, on the wedge, No doubt normal force acts in this direction. Normal force acts in this direction. When you resolve this normal force into components, one component in this direction, one component in this direction, it is theta, no? This is theta, no? So this component is n sin theta, this component is n cos theta. Because of n cos theta component here in downwards direction, the reaction force acts on the wedge in upward direction by the floor. That's why along vertical direction there is no acceleration. But along horizontal direction, whenever n sin theta acts on the inclined plane or wedge towards left, because of that, the wedge travel with certain acceleration. So what is that acceleration? N sin theta is equal to, on the wedge along horizontal direction towards left, only the force component acts is equal to n sin theta. So n sin theta is equal to mass of the wedge, that means capital M. Mass of the wedge is capital M into acceleration of the wedge. I think you better to write mass of the wedge, mass of the acceleration as separate. Mass of the block mb, you write. Mass of the wedge, you write small mw. Of course, we can use any formula. mb is equal to m, capital M is equal to mw, because mw means mass of the wedge. We are not having any confusion. So here, mass, here this can be written as, here you write mass of the wedge into acceleration of the wedge towards left, we imagine as AW. Here also, mass of the block, mass of the block, mass of the block. Okay. Here also, mass of the block, mass of the block. Okay. Now, this is another equation. In this already n, we are having formula from 6. N we are having mg cos theta minus mb into something we got, no? Here. So we substitute that value there. So from this formula, n is equal to, we can write mw aw by sin theta, no? This is equation 7. Now you substitute this n value from 7 in 6. 7 in 6 gives. 7 in 6 gives. Okay. 7, n is equal to something. N means this only, no? So mw aw by sin theta is equal to mg cos theta minus mg cos theta minus mg. Mg means mbg cos theta, no, it is mbg cos theta, because mass of the block, mbg cos theta minus mb aw sin theta. Okay. Now you write all aw terms aside. That means you bring this negative term to left and you take aw common. Okay. Then aw of mw by sin theta. Okay. Plus, already we have taken aw common. Remaining is mb sin theta. That's all. This is equal to mbg cos theta is there. mbg cos theta. Okay. Therefore, you take LCM. You take LCM. Okay. When you take LCM, aw of mw plus mb into sin theta LCM, you take sin square theta whole by sin theta is equal to mbg cos theta. Therefore, acceleration of the wedge, just you do cross multiplication. Acceleration of the wedge is equal to mbg sin theta cos theta by, here just you do cross multiplication. So when you do cross multiplication, then you will get mbg cos theta into sin theta. mbg cos theta into sin theta whole by mw plus mb sin square theta. mw plus mb sin square theta. So this is the formula for acceleration of the wedge. It is the formula for acceleration of the wedge. So mbg sin theta cos theta by mw plus mb sin square theta. Okay, next, what about AB? Acceleration of the wedge we got. Acceleration of the block means perpendicular to the incline. What about AB? Already we are having this relation, no? From 4. From 4, acceleration of the block is equal to AW into sin theta is there, no? So from this, AB is equal to AW means you write this one into sin theta. That means you will get sin square theta. That's all. MBZ cos theta into sin theta. That means sin square theta whole by MW plus mb sine square theta. This is the acceleration of the block perpendicular to the incline. Acceleration of the block perpendicular to the incline. Okay, here along the perpendicular to incline acceleration we know. Along this inclined surface, only the force acts on the block is equal to, in this direction, only the force acts on the block is equal to their weight component mg sin theta only. So with what acceleration the block travel along this direction means g sin theta only. So along incline, acceleration of block is equal to g sin theta only. So perpendicular to incline acceleration of block is known, parallel to incline acceleration of block is known. Okay, therefore resultant acceleration of the block is square root of this square plus square root of this square plus this square. Okay. So in that way we can find this is say a1, this is equal to say ab is equal to a1 and a2 is equal to g sin theta say. Therefore from the ground frame, when you observe the situation, acceleration of block, net acceleration of block A is equal to square root of a1 square plus a2 square. In this way, we can find the acceleration of the block. In this way, we can find the acceleration of the block. Okay. All of you, again, you listen this video so that you can understand again perfectly. Okay. Even then, if you are unable to understand, you ask me again. Right. This is the wedge constraint. Okay. Now, another example is there in this. Shall I erase this one? Shall I erase this one? Along inclined plane, normal force component on the body in this is in this direction. Their component is not there along incline now. Only weight component mg sin theta acts along the inclined plane. Okay, that's why along the inclined plane, what is the acceleration means mg sin theta is equal to m into a. So mm cancel, a is equal to g sin theta. That's why along the incline acceleration is equal to g sin theta. Along the incline acceleration is equal to g sin theta. Okay. Right. So now you see this diagram. Again, you see this video so that you can understand properly. One more wedge constraint is there. One more example. Example 2, in case of wedge constraint, of course, in wedge constraint, one more, another example 2. Suppose there is a smooth wedge. The wedge of angle of inclination theta is kept on the smooth horizontal surface, smooth surface. It is the smooth wedge. It is a smooth wedge having mass capital M. Okay, now one cylinder is restricted to move vertically downwards only. One cylinder is restricted to move vertically downwards only. Here, this is the one block. Okay, here this block is kept over the surface of the wedge, on the inclined surface of the wedge. Here the mass of this block is say m. Mass of this block is m. Here this block is restricted to move only along vertical direction because it is fixed between the two rigid walls. so that it can move freely along vertical direction only. It has no motion along horizontal direction. That means the motion of this body is restricted, no? The motion of this body is restricted. Okay, now whenever you release this block, you see, as this bottom surface of the block is in contact with the inclined surface, perpendicular to plane of contact, on this block, normal force is exerted. In this direction, normal force is exerted by this block on this wedge. Their component acts in this direction and vertically downwards direction. Because of this component, suppose this is a normal force, then in this direction, if it is theta, this is theta, no? Then normal force component in this direction is equal to n sine theta. Because of this n sine theta component, the wedge move towards right. That's why n sine theta is equal to as this is only the force acts on the wedge towards right. With this force, the wedge move towards right with an acceleration, say AW, with acceleration AW. So m mass of the wedge into acceleration of wedge along horizontal direction. So this is one relation we can have. Next, here you see, suppose this wedge, this block comes down with an acceleration, say AB. As this block is restricted to move along vertically downwards direction only. Suppose the block comes down with an acceleration AB and wedge can travel with an acceleration AW towards right because of this normal force component. What is the relation between AB and AW? That is our duty. That is our aim. We have to find the relation between AB and AW. We have to find the relation between AB and AW. Okay. ikkada oka smooth inclined surface మీద వెడ్జ్ నుంచి ఆ బ్లాక్ ని వెర్టికల్లీ డౌన్వర్స్ డైరెక్షన్ లో మూవ్ అయ్యేట్టుగా రిస్ట్రిక్ట్ చేశారు. అంటే రెండు వాల్స్ మధ్య ఈ బ్లాక్ ని ఫిక్స్ చేశారు. ద బ్లాక్ కెన్ మూవ్ ఓన్లీ అలాంగ్ వెర్టికల్ డైరెక్షన్. హారిజంటల్ డైరెక్షన్ మూవ్ కాదు. రెండు వాల్స్ మధ్య ఫిక్స్ చేశారు కాబట్టి హారిజంటల్ డైరెక్షన్ మూవ్ కాదు. అయితే ఇక్కడ స్మూత్ వాల్సే కాబట్టి దే కెన్ మూవ్ ఫ్రీలీ అలాంగ్ వెర్టికల్ డైరెక్షన్. Whenever the block is released, as the normal force component n sin theta acts on the wedge towards right, because of that the wedge travel in this direction. Whenever the wedge travel in this direction, you see after some time, if the wedge comes to this position, whenever the wedge comes to this position, at this time the block comes to this position, isn't it? Whenever the wedge comes to this position, the block is always in contact with the inclined surface of the wedge only. That's why whenever the wedge move in this direction, the block comes down here. Okay, now here whenever the block comes down with an acceleration AB and wedge move towards right with an acceleration AW, but always they maintain the contact between this block and wedge. ఇది ఇటువైపు మూవ్ అవుతూ ఇది క్రిందకు వస్తున్నా కూడా ఎప్పుడు కూడా వాటి యొక్క కాంటాక్ట్ లూజ్ కావు. కాంటాక్ట్ లూజ్ అయిందంటే అసలు యాక్సిలరేషన్ ఉండదు. కాంటాక్ట్ లూజ్ కాకుండా ఇది క్రిందకు వస్తూ ఉంటుంది, ఇది ఇటువైపు మూవ్ అవుతూ ఉంటుంది. అంటే ఇక్కడ స్టిల్ దేర్ ఈస్ ఎ కాంటాక్ట్ బిట్వీన్ ద బ్లాక్ అండ్ ద వెడ్జ్. ఆ కాంటాక్ట్ ఉన్నాయి కాబట్టి ఈ ప్లేన్ ఆఫ్ కాంటాక్ట్ పర్పెండిక్యులర్ గా ఉండే డైరెక్షన్ లో ఎటువంటి కాంటాక్ట్ లూజ్ కావట్లేదు. కాబట్టి యాజ్ ద ప్లేన్ ఆఫ్ కాంటాక్ట్ ఈస్ ఆల్వేస్ దే ఆర్ ఇన్ కాంటాక్ట్ ఈచ్ అదర్ ఓన్లీ. Perpendicular to the plane of contact, there is no change in the acceleration. So perpendicular to plane of contact means in this direction. In this direction, there is no change in the acceleration of the two. ఒకవేళ యాక్సిలరేషన్స్ డిఫరెంట్ గా ఉంటే ఈ రెండు కాంటాక్ట్ ఉన్న ప్లేన్స్ మధ్య సపరేషన్ ఉండేది. కానీ సపరేషన్ లేదు అంటే perpendicular to the plane of contact, accelerations of the block and wedge both are equal. That is the condition of the wedge constraint. So perpendicular to plane of contact, accelerations are same. Accelerations of block and wedge are same. That is very, very important. Perpendicular to the plane of contact, acceleration of the block and wedge are same. Okay, now, but acceleration of the block is in this direction. Acceleration of the block is in this direction. That means in vertically downwards direction like this. In this direction, acceleration of the block is AB. But perpendicular to the plane of contact, what is the acceleration we need? Okay, suppose if it is theta, then it is 90 minus theta, so it is 90 minus theta. As it is perpendicular, if it is 90 minus theta, it is theta, no? So in this direction, acceleration component of the block is equal to AB cos theta. Okay, In this direction, acceleration of the wedge is AW. Perpendicular to the plane of contact. In this direction, acceleration of the wedge is equal to, in this direction. If it is theta, this is theta. Then in this direction, acceleration of the wedge is equal to AW sine theta, no? In this direction, perpendicular to the plane of contact, acceleration of the wedge is equal to AW sine theta, because in this direction, acceleration of the wedge is AW. When you resolve them into components, one component in this direction, another component in this direction, perpendicular to plane of contact, the acceleration of the wedge in this direction is equal to AW sine theta. AW sine theta. So perpendicular to plane of contact, acceleration of the block is AB cos theta, acceleration of the wedge is AW sine theta. AW sine theta. Therefore, AB is equal to AW into sine theta by cos theta means tan theta, no? It is the constraint relation between these two. So this is very, very important relation. AB is equal to AW. AB is equal to AW into tan theta. Where AW is the, here the terms are very, very important. Where AW is the acceleration of the wedge along horizontal direction. AB is the acceleration of the block along vertically downwards direction. These points are important. Okay. In any case, a perpendicular plane of contact, you make the accelerations equal. That's all. Then you will get the acceleration of this block and this wedge also. Okay. That only one relation here we have here, as the motion of the block is restricted so that it is moving along vertical direction only. Suppose if it moves down with acceleration AB, whenever the wedge moves towards right with an acceleration AW, definitely whenever it moves down, the inclined surface comes down, no? ఇది ఇట్లా మూవ్ అవుతున్నప్పుడు సపోజ్ ఈ బ్లాక్ ఇక్కడే ఉంది, ఇంక్లైన్ ప్లేన్ ఇటువైపు మూవ్ అవుతున్నప్పుడు ఇక్కడికి వచ్చింది అనుకోండి, అప్పుడు గ్యాప్ ఉంది కదా, ఆ గ్యాప్ లోకి ఇది వస్తుంది ఇట్లా కిందకి. అంటే దిస్ బ్లాక్ ఈస్ హ్యావింగ్ acceleration vertically downwards and it is having acceleration horizontal direction, along horizontal direction. Okay, now here the condition is perpendicular to the plane of contact. This is the plane of contact of the block and wedge or inclined surface. Perpendicular to plane of contact, దీని యొక్క యాక్సిలేషన్ రెండు ఈక్వల్ అవుతాయి. దట్ ఈస్ ద ఫండమెంటల్. అయితే దీని యొక్క యాక్సిలేషన్ AB వెర్టికల్లీ డౌన్వర్డ్స్ డైరెక్షన్ లో ఉంది కదా, అప్పుడు పర్పెండిక్యులర్ టు ప్లేన్ ఆఫ్ కాంటాక్ట్, వాట్ ఇస్ ద యాక్సిలేషన్ కాంపోనెంట్ ఆఫ్ దిస్ బ్లాక్ పర్పెండిక్యులర్ టు ప్లేన్ ఆఫ్ కాంటాక్ట్. అట్లాగే the wedge is having acceleration AW towards right along horizontal direction. What is their component of acceleration perpendicular to plane of contact? That is equal to AW sin theta. For this block, perpendicular to plane of contact, acceleration is AB cos theta. For this wedge, perpendicular to plane of contact, acceleration is AW sin theta. These two must be same because always they maintain the contact here. ఈ రెండింటి మధ్య కాంటాక్ట్ ఎప్పుడు ఉంటుంది కాబట్టి ప్లేన్ ఆఫ్ కాంటాక్ట్ దగ్గర రెండు బాడీస్ కాంటాక్ట్ లో ఉన్నాయి కాబట్టి perpendicular plane of contact రెండిటికి యాక్సిలరేషన్ సేమ్ ఉండాలి, అదర్వైజ్ there is no contact. Okay, that's why AB cos theta is equal to AW sin theta. So from that AB is equal to AW into sin theta by cos theta means tan theta, no? It is the wedge constraint in this case. Okay, so that depends on the position of the blocks, the wedge constraint relations will be changed. For this case, this is the wedge constraint. Okay, now based on this we had to do the problems. Okay, right. Now all of you open your material. All of you open your our material, Chaitanya material. Next week you are having advanced exam. Okay, right. All of you open your material, Chaitanya material. We will do some problems today. I will say page number, everything. Okay, page number 158. Page number 158. No, page number 138. Page number 138. Page number 138. Okay, you see. Page number 138. All of you see in page number 138, problem number 1, 2. Already I said in the class, I think you have completed. Page number 138, problem number 1. I think you have completed. That is directly, I derived the formula also. Okay. I derived the problem here, page number 138, exercise 3. Page number 138, exercise 3, problem number 1, you see, already I completed in the concepts only. Okay. Next, second problem. Second problem, you see, all of you see the second problem. Lecture sheet, exercise 3, level 1, page number 138, problem number 2. A railway engine of mass 50 ton is pulling a wagon of mass 40 tons with a force of 4,500 Newton. The resisting force acting in 1 Newton is 1 Newton per ton. The tension in the coupling between the engine and the wagon is. Suppose here there is a wagon. Here this wagon is coupled to the engine. This wagon is coupled to the engine like this. This wagon is coupled to the engine like this. Okay. Now here a railway engine of mass of the railway engine, that means this one, that is equal to 50 ton. Okay, therefore mass M1 is equal to 50 ton. 1 ton means how many kgs? 1 ton is equal to how many kgs? 1 ton is equal to how many kgs? 1000 kgs, no? So 1 ton is equal to 1000 kgs. So that is equal to 5 into 10 to the power 4 kgs. It is the mass of the engine. Mass of the wagon, M2. That mass of the wagon is 40 ton. So 40 into 1000. That is equal to 4 into 10 to the power 4 kgs. It is the mass of the wagon. Here the engine pulls the wagon by coupling. Of course, in between any two compartments, coupling is there, no? Okay, now a railway engine of mass 50 ton. Here 1 ton is equal to 1000 kgs. 1 ton is equal to 1000 kgs. Okay. A railway engine of mass 50 tons is pulling a wagon of mass 40 tons with a force of 4500. With a force of 4500. Okay. Newton. The resistance force acting is 1 Newton per ton. రెసిస్టెన్స్ ఫోర్స్ అంటే దీని మీద ఈ వ్యాగన్ కి ట్రాక్ కి మధ్య రెసిస్టెన్స్ ఫోర్స్ ఉంటుంది, ఇక్కడ రెసిస్టెన్స్ ఫోర్స్ ఉంటుంది. ఇక్కడ రెసిస్టెన్స్ ఫోర్స్ F1 అనుకోండి, ఇక్కడ రెసిస్టెన్స్ ఫోర్స్ F2 అనుకోండి. ఓకే, F1 F2 దట్ ఈస్ ద రెసిస్టెన్స్ ఫోర్స్. ఆ రెసిస్టెన్స్ ఫోర్స్ 1 న్యూటన్ పర్ టన్ ఇచ్చాడు. 1 న్యూటన్ పర్ టన్ అంటే ఒకసారి ఇక్కడ చూడండి, F1 ఇస్ ఈక్వల్ టు దీని యొక్క మాస్ 50 టన్. 1 న్యూటన్ పర్ టన్ అంటే మరి 50 న్యూటన్స్ ఇక్కడ రెసిస్టెన్స్ ఫోర్స్ ఉన్నట్లేగా, 50 న్యూటన్. అదే ఇక్కడ F2 అయితే 1 టన్ మాస్ కి 1 న్యూటన్, సారీ 1 టన్ కి 1 న్యూటన్ రెసిస్టెన్స్ ఫోర్స్ పనిచేస్తా ఉంది. రెసిస్టెన్స్ ఈజ్ ఈక్వల్ టు 1 న్యూటన్ పర్ టన్ అని ఇచ్చాడు. అంటే ఒక టన్కి 1 న్యూటన్ రెసిస్టెన్స్ ఫోర్స్ పనిచేస్తా ఉంది. మరి దీని యొక్క మాస్ m2 కాబట్టి ఇక్కడ రెసిస్టెన్స్ ఫోర్స్ ఎంత? m2 ఇంటూ 1 న్యూటన్ పర్ టన్. 1 న్యూటన్ పర్ టన్. m2ని ఇక్కడ టన్స్ లో సబ్స్టిట్యూట్ చేయాలి. ఎందుకంటే న్యూటన్ పర్ టన్ లో ఇచ్చాడు కాబట్టి. m2 అంటే 40 కాబట్టి therefore 40 న్యూటన్. ఇట్ ఈస్ ద రెసిస్టెన్స్ ఫోర్స్. ఓకే. సో therefore ఈ సిస్టమ్ మీద ముందుకు మూవ్ అవడానికి అప్లై చేసిన టోటల్ ఫోర్స్ ఎంత? టోటల్ ఫోర్స్ ఈజ్ ఈక్వల్ టు 4500 న్యూటన్ ఇచ్చాడుగా. టోటల్ ఫోర్స్ ఈజ్ ఈక్వల్ టు 4500 న్యూటన్ అని ఇచ్చాడు. ఓకే. therefore మరి టోటల్ ఫోర్స్ వల్ల రెండు మూవ్ అవ్వాలి కదా. అప్పుడు నెట్ ఫోర్స్ యాక్ట్స్ ఆన్ ది ఎంటైర్ సిస్టమ్ ఈజ్ ఈక్వల్ టు అప్లైడ్ ఫోర్స్ మైనస్ ఈ ఫ్రిక్షనల్ ఫోర్స్. ఈ రెండింటిని అపోజ్ చేస్తూ ఇటువైపు ఫ్రిక్షనల్ ఫోర్స్ ఉంది కదా, కాబట్టి F1 ప్లస్ F2. ఇది నెట్ ఫోర్స్ యాక్ట్స్ ఆన్ ది ఎంటైర్ సిస్టమ్. దట్ ఈస్ ఈక్వల్ టు మాస్ ఆఫ్ ది ఎంటైర్ సిస్టమ్ M1 ప్లస్ M2 ఇంటూ యాక్సిలరేషన్ A. వాడు అడిగింది వాట్ ఈస్ ద టెన్షన్. ఓకే, వాట్ ఈస్ ద టెన్షన్ ఇన్ ద కప్లింగ్. ఇక్కడ టెన్షన్ ఎంతో అడిగాడు రా, ఇక్కడ టెన్షన్ అడిగాడు వాడు. సరే, ముందు అసలు యాక్సిలరేషన్ పాయింట్ అవుట్ చేద్దాం. యాక్సిలరేషన్ A is equal to F minus F1 plus F2 by M1 plus M2. That is equal to 4500 minus F1 plus F2 means F1 plus F2 means 50 plus 40 whole by M1 plus M2 అంటే 9 into 10 power 4 రాసుకోవచ్చు డైరెక్ట్ గా. 9 into 10 power 4. Therefore acceleration A is equal to, therefore when you simplify them, you will get acceleration is equal to, what is the acceleration you will get? You see 4500 minus 90 అంటే 4410 okay by 9 into 10 power 4. 9 into 10 power 4. It is the acceleration. Okay, you keep like this much meter per second square. This much meter per second square. Now what is the tension here? Whenever the engine is moving in this direction, the coupling only pulls the wagon in this direction. That's why force acts on the wagon in this direction is equal to tension, or that is the tension in the coupling. This tension only pulls in this direction. So on this wagon, what are the forces acts on the wagon of mass M2? What is the force acts? Tension in this direction and frictional force F2 in opposite direction. Even then, as the both entire wagon and engine travel with acceleration A, wagon also travel with the same acceleration in this direction along with the engine. That's why tension is greater, no? So T minus F2 is equal to mass of this wagon into acceleration A. They asked the tension. T is equal to M2A plus F2. So you substitute the data. M2A. So M2 means this one, no? 44 into 10 power 4 into A means this one, 4410 by 9 into 10 power 4 plus F2 is equal to 40 Newton. F2 is equal to 40 Newton. Here 10 power 4 cancel. Okay, 9, is it divisible with 9 or not? 9 తోటి పోతుందా? 9 4s are 36. Okay, 9 4s are 36. 36 means 8 remainder, 81. 9 9s are 0. 4 into 490, 0. 1960 plus 40. Therefore tension in the coupling is equal to 2000 Newton. Tension in the coupling is equal to 2000 Newton. Yeah, 2000 Newton is the answer. Tension in the coupling is equal to 2000 Newton. Tension in the coupling is 2000 Newton. Is screen sharing is properly visible to you or not? Is screen sharing is properly visible to you or not? Okay. Okay. If anybody is not getting screen sharing properly, you adjust your system, because for the people, most of the people, they are getting properly. They are getting screen sharing properly. Okay. Next. Shall I raise this problem? Shall I raise this one? Okay. Next we see another problem. Next you see which problem? Third problem, I think previously completed, I think. Third problem. Third problem. Is third problem completed or not? Is it done by you or not? No, no, 2000 you will get. 2000 you will get. Likit. Already I did the problem, no? Already I did the problem. That is the answer. Okay. You see the calculation, Likit. You see third problem. Third problem. I think third problem you had done previously. Not completed. Okay, Likit, you got? Okay. Right. Not completed. Okay. You see, there are 3 diagrams are given. In all the diagrams, what is the acceleration they asked? Okay, you see, here the string is passed over the pulley. At one end, a load of mass m is suspended, and at the other end, by pulling, here it is pulled with a force to mg. Similarly, here it is the active mission. Here again, it is pulling with a force equal to mg in downwards direction. Whatever the accelerations of the blocks they asked. Here you see, as no block is here, if this end of the string is pulled with a force F is equal to 2 mg, that is only the tension in the string. The same tension is equal to F only. Here also tension is equal to F only. F means 2 mg. That means on this block, 2 mg force acts upwards and mg downwards. Even definitely, as this force is greater, definitely in first case it move upwards. So net force is equal to T minus mg. That is equal to mass of the block into acceleration A1 in first case. T means 2 mg minus mg is equal to m into A1. Or A1 is equal to, we can write G only, no? G upwards or downwards? As it move upwards. So this is the acceleration of the first block. Next, in this case, it is the active mission. Different masses. So no doubt, as this mass is greater than this one, definitely the block, this block comes down, this block rises up. Second diagram lo acceleration A2 anukunte. So A2 formula enti? A2 is equal to net force in this direction, or m2 minus m1 by m2 plus m1 into g. We can write like that also. Net force in this direction is 2 mg minus mg. It is the net force by total mass of the system, 2m plus m. Like this also we can write. Total force acts on the 2 blocks in this direction by total mass of the system. That is the acceleration of the 2 blocks. That is equal to mg by 3m. That means g by 3, no? G by 3. So A2 is equal to g by 3. Okay, this is the acceleration in second case. In this case, here you see, as this string is directly pulling with a force F, that is only the tension T. T is equal to F. is equal to mg. The same tension acts in this direction. T is equal to mg. So on the block M, T is equal to mg force acts upwards and mg downwards. That's why net force is 0 now. Whenever net force is 0, acceleration of the block in third diagram is equal to 0 itself. So what is the relation among the accelerations? Greater than, less than, something like it is given like that. No doubt A1 is greater, next this one, next to this one. So A1 greater than A2 greater than A3. This is the relation among the accelerations. That is the relation among the accelerations. Okay. ఏనా దీంట్లో లిఖిత్ నువ్వు వింటలా సరిగా? ఇక్కడ ఈ స్ట్రింగ్ యొక్క ఎండ్ పట్టుకుని డౌన్వర్డ్స్ డైరెక్షన్ లో 2 mg ఫోర్స్ తో పుల్ చేస్తున్నాడు. ఇక్కడ వేరే బ్లాక్ ఏం లేదు కాబట్టి ఎంత ఫోర్స్ తో పుల్ చేస్తామో అదే టెన్షన్ అవుతుంది. ఇదే టెన్షన్ మొత్తం ఒకే స్ట్రింగ్ కాబట్టి సేమ్ టెన్షన్ T is equal to 2 mg యాక్ట్స్ ఆన్ ది బ్లాక్ అప్వర్డ్స్, mg డౌన్వర్డ్స్. అప్పుడు ఈ ఫోర్స్ గ్రేటర్ కాబట్టి నెట్ ఫోర్స్ అంటే ఈ డైరెక్షన్ లో T మైనస్ mg నే కదా. T మైనస్ mg is equal to మాస్ ఆఫ్ ది బ్లాక్ ఇంటూ యాక్సిలరేషన్ ఆఫ్ ది బ్లాక్ A1. T అంటే 2 mg సబ్స్టిట్యూట్ చేస్తాం. ఇంకా దాంట్లో అర్థంగానే ఉంది. అట్లాగే నెక్స్ట్ వన్, ఇది యాక్టివిటీ మిషన్ కాబట్టి డైరెక్ట్ గా నీకు తెలుసు కదా యాక్టివిటీ మిషన్ అంటే. యాక్టివిటీ మిషన్ లో 2 mg ఫోర్స్ ఇటువైపు ఉంది, mg ఫోర్స్ ఇటువైపు ఉంది. అయినప్పటికీ ఇది ఎక్కువ ఉంది కాబట్టి దిస్ 2 బ్లాక్స్ మూవ్ లైక్ దిస్. అప్పుడు వాట్ ఈస్ ద నెట్ ఫోర్స్ యాక్ట్స్ ఆన్ ది 2 బ్లాక్ సిస్టమ్? 2 mg మైనస్ mg. ఈ నెట్ ఫోర్స్ వలన 2 బ్లాక్స్ మూవ్ అవుతున్నాయి కాబట్టి ఈ పాత్ లో టోటల్ మాస్ మూవ్ 2m ప్లస్ m g/3. ఇక్కడ సేమ్ టెన్షన్ T is equal to mg, ఇక్కడ mg నే కాబట్టి ఇక్కడ నెట్ ఫోర్స్ 0, అందువల్ల యాక్సిలరేషన్ ఉండదు. అంటే A3 is equal to 0. Net force 0 అయినప్పుడు the body may be at rest or may be moving with constant velocity. Okay. Right. Okay, Likith. Right. Next you see fourth problem. A uniform rod of length 60 cm and mass 6 kg. Uniform rod of length is equal to 60 cm and mass is equal to 60 kg. 6 kg pulled with forces towards right with a force F1 is equal to 45 Newton and F2 is equal to 21 Newton. I think you have done this problem. I have given homework to you. Then what is the tension here exactly at this point, which is at a distance 15 centimeter? What is the tension in the string? T is equal to question mark. Tension the rod ఎంతో క్యాలిక్యులేట్ చేయమన్నాడు. మరి ఇది 15 అయినప్పుడు డెఫినెట్ గా 60 కాబట్టి టోటల్ లెంత్ ఇది 45 అవుతుంది కదా, 45 సెంటీమీటర్. ఇక్కడ టెన్షన్ అడిగినప్పుడు ఫస్ట్ ఫార్ములాస్ డైరెక్ట్ గా ఐడియా ఉంటే డైరెక్ట్ గా చేయొచ్చు. వీఆర్ హ్యావింగ్ ఫార్ములా tension T is equal to F1 into 1 minus x by L plus F2 into x by L. We are having that formula. If you are not having idea, of course you don't remember the formula. Based on the concepts only we have to do. As this on the total rod in this direction 45 Newton force is applied, and in this 45 Newton is applied in this direction, 21 Newton is applied. 21. As this force is greater, net force acts on the rod is equal to F1 minus F2. That is equal to mass of the rod into acceleration A. So first you find the acceleration. F1 means 45 minus it is 21 is equal to mass means 6 into A. Implies A is equal to 45 minus 21 means that is equal to 24. 24 by 6 means 4, no? 4 meter per second square. It is the acceleration of the rod. Okay, now you consider this part or this part. Any part we can find. Suppose if we consider this part, actually we pulled this part with force F1, but at the same time the remaining part pulls this part, opposes the motion of this part in forward direction as both are joined. That's why tension acts on this part is in this direction. Suppose ikkada tension T anukunte, just you consider this part. This length is equal to 45 centimeter. Here F1 force is applied in this direction, tension T in this direction. Okay, no doubt as the entire rod move with acceleration A towards right, definitely this part, every part of the rod also travel with the same acceleration towards right. So net force is equal to F1 minus T. That is equal to mass of this part is say m dash into acceleration A. F1 means that is 45 minus tension we have to find. Mass of this part means total mass is 6 kg for this much length. So mass per unit length means 6 by 60 centimeter. We have substituted in centimeter. For this much length, what is the mass? Means into 45. Here it is substituted in centimeter. It is also substituted in centimeters only. 27, no? 27 Newton. Yeah, 27 Newton. That is the answer. 27 Newton. That is the answer. Okay. So last problem in this chapter, in this exercise, fifth problem. Fifth problem. All of you see the fifth problem also. Last problem. Today, based on these constraint relations, you have to do the problems. Okay. Last problem here, fifth problem. Tomorrow I want to discuss problems mainly. Spring concept and problems only. Okay. ఏంటా ప్రతిదీ డయాగ్రామ్ మళ్ళీ ఏంటి అసలు? విభు, వాట్ ఈస్ అవర్ ప్రాబ్లం? విష్ణు, ఇది ఆల్రెడీ చెప్పిన కాన్సెప్ట్ నే మళ్ళీ చెప్పాను, ప్రాబ్లం చెప్పాను నేను. ఒక యూనిఫామ్ రాడ్ మీద ఇటువైపుకి F1 ఫోర్స్, ఇటువైపుకి F2 ఫోర్స్ అప్లై చేసినప్పుడు ఈ ఫోర్స్ గ్రేటర్ కాబట్టి ద ఎంటైర్ రాడ్ విల్ మూవ్ ఇన్ దిస్ డైరెక్షన్ విత్ సర్టన్ యాక్సలరేషన్. నెట్ ఫోర్స్ ఎంత ఈ డైరెక్షన్ లో? ఇది గ్రేటర్ దీనికంటే. అప్పుడు నెట్ ఫోర్స్ అంటే దిస్ మైనస్ దిస్ ఈజ్ ఈక్వల్ టు నెట్ ఫోర్స్, దట్ ఈస్ ఈక్వల్ టు మాస్ ఇంటూ యాక్సలరేషన్ అకార్డింగ్ టు న్యూటన్స్ సెకండ్ లా ఆఫ్ మోషన్. F1 F2 వాల్యూ సబ్స్టిట్యూట్ చేసేయండి. M అంటే 6 ఇచ్చాడు ఇంటూ యాక్సలరేషన్. దాని నుంచి సింప్లిఫై చేస్తే A ఈజ్ ఈక్వల్ టు 4 అయితే వాడు అడిగింది ఇక్కడ టెన్షన్ అడిగాడు. సో ఈ పార్ట్ ఒకదాన్ని కన్సిడర్ చేయండి. మన యాక్చువల్ గా ఫోర్స్ ని అప్లై చేస్తుంది ఈ పార్ట్ మీద ఇటువైపుకి. ఇప్పుడు ఇది ఒక్కటి ఫ్రీగా మూవ్ అవ్వట్లేదు కదా, అంటే ఇటువైపు మూవ్ అయ్యేటప్పుడు ఈ రిమైనింగ్ పార్ట్ దీన్ని కొంత ఫోర్స్ ఇటువైపు పుల్ చేస్తూ ఉంటుంది. ద ఫోర్స్ విత్ విచ్ ద రిమైనింగ్ పార్ట్ పుల్స్ దిస్ పార్ట్ ఇన్ దిస్ డైరెక్షన్, దట్ ఈస్ ద టెన్షన్. ఆ టెన్షన్ క్యాలిక్యులేట్ చేయమన్నాడు. లేదు ఇది తీసుకున్నాం అనుకోండి, ఈ పార్ట్ ఇటువైపు పుల్ చేస్తా ఉంది. ఇక్కడ ఎంత ఫోర్స్ తో ఈ పార్ట్ దీన్ని ఇటువైపు పుల్ చేస్తుందో దట్ ఈస్ ద టెన్షన్. అది ఇటువైపు ఉంటుంది ఈ పార్ట్ కన్సిడర్ చేసినప్పుడు. మనం ఇది కన్సిడర్ చేస్తాం కాబట్టి ఇటువైపు ఉంది. ఈ ఫోర్సెస్ ఈ పార్ట్ మీద ఒకటి ఇటు పనిచేస్తున్నా కూడా ఈ ఎంటైర్ రాడ్ ఏ యాక్సిలరేషన్ తో ఇటువైపు మూవ్ అవుతుందంటే ఈ పార్ట్ ఏ యాక్సిలరేషన్ తో మూవ్ అవుతుందంటే ఈ పార్ట్ కూడా ఏ యాక్సిలరేషన్ తో మూవ్ అవుతున్నట్లే. కాబట్టి ఇది ఏ యాక్సిలరేషన్ తో మూవ్ అవుతున్నట్లేగా, అంటే 4 మీటర్ పర్ సెకండ్ స్క్వేర్. నెట్ ఫోర్స్ ఎంత? F1 మైనస్ T ఈజ్ ఈక్వల్ టు మాస్ ఆఫ్ దిస్ పార్ట్ ఇంటూ యాక్సిలరేషన్. మాస్ ఆఫ్ దిస్ పార్ట్ అంటే టోటల్ మాస్, ఈ రాడ్ యొక్క టోటల్ మాస్ ఇచ్చాడు ఇంత లెంత్ కి. మరి ఈ లెంత్ కి మాస్ ఎంత? ఇక్కడ యూనిట్ లెంత్ కి మాస్ ఎంత అంటే 6 by 60 సెంటీమీటర్, అంటే 1 సెంటీమీటర్ కి మాస్ ఇది. మరి 45 సెంటీమీటర్ కి మాస్ ఎంత అంటే ఇంటూ 45 కదా. దాన్ని సింప్లిఫై చేస్తే సంథింగ్ 18 ఏదో వచ్చింది. దాని నుంచి T ఈజ్ ఈక్వల్ టు అఫ్ కోర్స్ ఇంటూ యాక్సలరేషన్ 4 సబ్స్టిట్యూట్ చేసి సింప్లిఫై చేస్తే 27 వచ్చింది. ఓకే. Okay, these concepts are there in integrated material. Already number of times I said the concepts, most of the concepts are in integrated material. Okay, fifth problem. Two masses 2 kg and 5 kg. Two masses 2 kg and 5 kg are joined by means of M1 is equal to 2 kg, M2 is equal to 5 kg. They are kept on the smooth horizontal surface and it is pulled by a force F is equal to 1 Newton. Okay, now a constant force 1 Newton is applied on 5 kg mass as shown. 2 seconds later, the string connecting the masses is cut before F continues to act. Okay, after 2 more seconds. Okay, first of all, with what acceleration the system will move? With what acceleration the system will move? First we have to find. Okay, on the entire system, here on the 2 blocks together, the force applied is this one. Okay, F is equal to, for this force the 2 blocks move together, that's why total mass M1 plus M2 into common acceleration A. Then A is equal to F means 1 by M1 plus M2 means 2 plus it is 5, no, that is equal to 1 by 7 meter per second square. So both blocks move with same acceleration. Here they asked to find. Okay, both, first option, both masses move with an acceleration 1 by 7. That is correct only, no? Okay, now 2 seconds later, the string connecting the masses is cut, but F continues to act. Okay. After 2 seconds, 2 seconds తర్వాత దీన్ని కట్ చేశాడు. అయితే ఆ 2 seconds లో మరి as the system travel with an acceleration A, after 2 seconds, in 2 seconds, what is the velocity acquired by this and this? Both are same. So velocity acquired is how much? Initial velocity is 0. Acceleration, the two blocks move together with acceleration 1/7. And after 2 seconds, what is the velocity of the system? So from V is equal to U plus AT, we have to find U0 plus A means 1/7 into time means 2, that is equal to 2/7. That means two blocks move together with velocity 2/7 meter per second in 2 seconds. After 2 seconds, they are having velocity this one. At that time, the string is cut. When string is cut, then this block, whenever the string is cut, and this force is applied continuously. Even after string is cut, the same force is continued. But whenever string is cut, there is no force acts on the block to move to in this direction. But at the time, whenever the string is cut, as the velocity of two blocks is 2/7, even after string is cut also, the velocity of first block is 2/7 only. But as these two are not joined together, the velocity of this body never increases. That's why velocity of the first body after string is cut is 2/7. Okay. Next. So both are having velocity 2/7. After two more seconds. After 2 more seconds means after any time as the string is cut, this velocity does not change. So first block is having velocity this only. But what about the velocity of this body after 2 seconds? For M2, after 2 seconds velocity we have to find. Initial velocity is at the instant whenever the string is cut, the velocity of this block both are same, that is equal to 2/7. That's why initial velocity for this block is 2/7 after string is cut, plus acceleration. What is the acceleration? Here, whenever the string is cut, this force acts only on this mass. That's why force by mass M2 is the acceleration into time. After 2 seconds more they asked. So 2/7 plus F means 1 by M2 means 5 into 2. Sorry, okay, 2, right. This is equal to, when you take LCM, then you will get 35. Here 10 plus 14, 29/35. 29/35. Okay, here you see. This is the answer. Okay. Right. Okay, for lighter body already 2/7 is the answer. This is the answer. Okay. Right now, have a nice day. Today, based on this constant relation, you have to do the problems. Okay. Right. Okay, I'm signing out. (24/35). 24. Yeah. Okay, 24/35. Right. 24/35 is the answer. Okay. Okay, now 24/35. That is the answer. Right. Okay, I'm signing out. Third option. Lighter body possesses a velocity 2/7 and heavier body possesses acceleration 1/7. Acceleration of heavier body is, you see here, 1/5 only, no? After 2 seconds, only the force acts on the second body. That's why acceleration of the second body is equal to F by M2. F is equal to 1/M2 means 5, 1/5 meter per second square. So acceleration of the second body is 1/5 meter per second square, and acceleration of velocity of the lighter body is 2/7 only. That means fourth option is correct now. Fourth option is correct and first option is also correct now. Fourth and first both are correct. Right, Nana? Have a nice day. I'm signing out.